Hello my dear students, today I am going to discuss chapter in trigonometry branch, trigonometric ratios or trigonometric functions. The basic definition of trigonometric ratio is ratio between any two sides of a right angle triangle is called a trigonometric ratio. Trigonometric ratio means ratio between any two sides of a right angle triangle. Suppose ABC is a right angle triangle, B at B 90 and at A it is acute angle. Now opposite to theta it is called opposite side, and this is adjacent side, and this is hypotenuse. Now ratio between any two sides of a right angle triangle is nothing but trigonometric ratio. Fundamental trigonometric ratios defined like this: sin theta, cos theta, tan theta. Sin theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is sin theta by cos theta, opposite side by adjacent side. So fundamentally three trigonometric ratios. Sin theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is opposite side by adjacent side, that is indirectly sin theta by cos theta. Fundamental. Reciprocal trigonometric ratios: cosec as 1 by sin, secant as 1 by cos, cot as 1 by tan theta. Now here three reciprocal trigonometric ratios for sin, cos, tan. Cosec as reciprocal of sin, secant as reciprocal of cos, cot as reciprocal of tan. The total 6 called trigonometric ratios. First three fundamental trigonometric, basic trigonometric ratios, and the next three reciprocal trigonometric ratios. So our chapter is trigonometric ratios. Now simplified formulas like sin theta multiplied by cosec theta is equal to 1, cos theta multiplied by secant theta 1, tan theta multiplied by cot theta 1, because both are reciprocals. Next. Before going to trigonometric ratio, before going to discuss various problems involved in trigonometric ratio or trigonometric function chapter, now I am giving simple definition of angle and classification. Angle is nothing but the portion intercepted between two intersecting lines. The portion included between two intersecting lines is called angle, this portion, or the amount of rotation from initial side to final side. Final side is obtained by rotating initial side at a fixed point vertex. That amount of rotation is called angle. This is final side, this is initial side. So that amount of rotation is called angle. Or with reference to fixed point, this is a moving side. If it is side is fixed here, initial side is fixed, moving side may be rotated up or down. The amount of rotation such that the final side is formed from the initial side is called angle. So the basic definition of angle, now I think it is clear. Now classification of angles, because in trigonometry branch first chapter many types of classification of angles. Classification, right, you know very well from lower class onwards. Angle definitions, angle classifications. Acute angle less than 90 is acute angle. Obtuse, angle more than 90 it is obtuse. Angle equal to 90 it is right angle. Angle equal to 180 straight angle. Angle more than 180 is called reflexive angle. And classification: clockwise angle, anti-clockwise angle. Angle observed in clockwise direction is called clockwise, and angle observed in anti-clockwise or counterclockwise is anti-clockwise angle. Complementary angle: if two angles sum is 90, then individual angles said to be complementary. If alpha plus beta equal to 90, alpha and beta are said to be complementary. If alpha plus beta equal to 180, individually alpha beta are called supplementary. If alpha plus beta 360, individually they are called quaternion angles. Next, 0, 90, 180, 270, 360, like that, 450, 540 and so on. The angles that are exactly coincide with quadrant axis called named specially quadrantal angles. Quadrantal angles. Conveniently, we divide the total plane angle as criteria. It will be like this quadrant system, 1, 2, 3, and this will be fourth quadrant. Theta ranging from 0 to 90 and 90 to 180, 180 to 270, it will be 360. In between 0 to 90 it is acute angle, it will be first quadrant. It will 90 to 180 exactly, 90 in between 90 to 180 second quadrant, 180 to 270 third quadrant, 270 to 360 fourth quadrant, according to the angle as criteria. Suppose if you observe in 2D Cartesian rectangular geometry, as coordinate x coordinate and y coordinate, abscissa and ordinate, divided as plus plus in first quadrant, minus plus second quadrant, minus minus third quadrant, plus minus fourth quadrant as a Cartesian coordinate. Now I am giving quadrant system according to the angle as criteria, first quad, second, third, fourth. Now sign scheme of various trigonometric ratios. Sign scheme means a sign convention, not scheme. Sign convention of various trigonometric ratios. Already we discussed sine to cot. Sin theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is opposite by adjacent, and cosec, secant and cot. Now in first quadrant all trigonometric ratios are positive. In second quadrant sin theta, cosec theta positive, remaining all other four negative. Here in third quadrant tan cot positive. In fourth quadrant it will be cos secant positive, remaining all are negative. As a quadrant sign scheme, a thumb rule. Now a thumb rule used frequently, a thumb rule used for the sign convention of various trigonometric ratios. All Sachin Tendulkar centuries. A thumb rule, like all silver teacups. All silver teacups means in first quadrant all are positive, in first quadrant all are positive. In second quadrant sine and cosec, like Sachin, S and sine and cosec and reciprocal. Tendulkar, T, third quadrant tan cot positive. Here Tendulkar is the first letter is T. Here first letter is C, fourth quadrant cos secant positive, remaining all are negative. So sign scheme ASTC. All silver teacups. Here all Sachin Tendulkar centuries. A thumb rule followed for a sign convention of various trigonometric ratios. Now one important link in first trigonometric ratio chapter is basic trigonometric identities. Trigonometric identities. Sin square theta plus cos square theta equal to 1, secant square minus tan square equal to 1, and cosec square theta minus cot square theta equal to 1. Now here factorization, sec plus tan into sec minus tan, sec plus tan bracket sec minus tan. Here cosec plus cot into cosec minus cot. So three are identical, three name called trigonometric identities, mostly used in converting one ratio into the other. Here converting cos in terms of sine, sine in terms of cos. Here secant in terms of tan, tan in terms of cot, tan in terms of sec, cosec in terms of cot, cot in terms of cosec. And also the advantage of three trigonometric identities helpful in elimination operation, elimination process. Elimination, very important term, important concept. Arranging relation between variables and constants by make use of three trigonometric identities is called elimination. Elimination, arranging relation between variables, arranging relation between variables and constant, arranging relation between variables and constants by make use of three trigonometric identities. Sin square plus cos square 1, 6 square minus tan square 1, cos square minus cot square equal to 1. A preoccupied idea, connection with variables and constant by make use of three trigonometric identities. Suppose with simple example elimination word, for understanding purpose, if x is equal to sec plus tan and y is secant theta minus tan theta. Now elimination of theta means in my mind I have preoccupied idea 6 square minus tan square one popular identity, trigonometric identity, and by make use of that formula now I go by mathematical operation multiplying the above data, above two equations. Multiplying is the logic here. Mathematical operation multiplying both x, y, a plus b into a minus b, sec plus tan into sec minus tan, 6 square minus tan square 1. So relation between variables x and y with constant 1 by make use of trigonometric identity 6 square minus tan square equal to 1. The elimination operation completed. So brief idea of elimination, and in detail very good questionnaire in elimination chapter. Elimination is not only here, elimination used in locus conditions, eliminations used in eliminating arbitrary constant by the method of differentiation in formation concept in differential equation chapter, and very important link elimination, eliminating one parameter, eliminating two parameters from the given data, elimination in locus problems in geometry. Okay, in detail we'll discuss, don't worry about the elimination concept. Now I am giving simple idea of graph knowledge of sin x, right? Concentrate. Y equal to f of x is sin x is a trigonometric function. Trigonometric ratio sin to cot, indirectly trigonometric ratio is nothing but a function, trigonometric function name called sin trigonometric function. Function means it is a mapping from input set to output set. Function symbol, and function is nothing but relation between two non-empty sets such that each x belongs to there exists unique y belongs to b. So function means sin x is a trigonometric function. Function means here y dependent variable and independent variable. By giving x value we get y values. By drawing the graph we get the shape of the trigonometric function. Sin x is a input is r to output is in between -1 to 1. Now it will be domain, it will be function like it will be second set, output set, codomain. Set of images is nothing but the range. So domain A and codomain B, and range is set of images, indirectly range is subset of the codomain. Right, now concentrate. Y equal to sin x. By choosing x values, you are getting y values. Suppose x at 0 degrees, y equal to sin 0 degrees, 0. If I put x 45, sin 45, 1 by root 2, 0.707. Okay, now before that standard values I am going to discuss of various standard angles involved in first chapter trigonometric ratios. You know very well 0, 30, 45, 60, 90, 180 standard results, standard angles, sin, cos, tan like this, and cosec and secant and cot can be reciprocal of the remaining, reciprocal of the standard. Now you know very well, my dear students, basic standard value, standard angles, standard means sin 0, 0, sin 31 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 91, sin 180 0, cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2, and cos 60 1 by 2, cos 90 0, cos 180 minus 1, tan 0 0, tan 30 1 by root 3, sin by cos, tan 45, tan 60 it will be not defined, tan 90 and it will be 0. So based on that I am using here x 45 degrees. Before going to this radian system, degree system and grade system, measuring of an angle, there is a connection. Pi radian equal to 180 degrees is equal to 200 grades. 1 radian roughly 57 degrees 14 minutes 22 seconds. 1 radian is equal to 57 degrees. So there is a conversion formula. Standard is pi by 2 radian equal to 90 degrees. Pi means 180 degrees is a straight angle. So pi radian 180 degrees is now used formula converting one system of angle into the other system. It will be radian system, it will be degree system. So pi by 4 is 45, 1 by root 2 0.707. next to 60, I think I am going to take 60 and also 30 also here. X 30, pi by 6, y equal to sine 30, it will be 1 by 2 as 0.5. It will be now pi by 6 means 30, pi by 3 means 60, 1 by, so root 3 by 2, 1.732 by 2, 0.86, and x will be 90, so y sine 90 degrees will be 1. Now, by make use of standard angles, x input given, now output y obtained. Now taking x-axis on graph and y-axis and plotting, we get the shape of sin x in the interval. Right, now concentrate. Important graph I am drawing, simple elementary graph. x0, y0, x30 it will be 0.5 like this, and 45 0.707 and 0.86, and at 90 it will be 1. Suppose if I take like this, it will be 90 and it will be pi, and if I substitute pi sin 180 0 from allied angle. Allied angle, how to calculate? What is the meaning of allied angle? Allied angle means you know very well, 0 90 180 270 360, the combination 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, 360 plus or minus theta are called allied angle combination. By knowing allied angle and quadrantal angle knowledge, we can get the values of given input x value and getting y values, taking x-axis as the plotting x values and getting output as y on y-axis. So sin 91 and sin 180 0, it will be like this, sin 91, okay, it will be like this, sin 30, it will be 0.5, sin 5 like 1 by 0.07, 0.707, 60, it will be 0.8, like it is increasing, like increasing. Now if I draw with a smooth curve, we got the points like this, and at 90 and it will be 0, means it will be like this, again decreasing. In between 0 to pi by 2 sin x is increasing, pi by 2 to pi if you observe by giving another value, suppose 90, 120, so 2 pi by 3, so 120. Allied angle knowledge, there is a formula for allied angle, we'll discuss later. The idea of getting the values of sin 120, sin 90 plus 30, cos 30, root 3 by 2, positive 0.86, so it will be decreasing again like this by giving different values, 120, 150, like that, near to 180 it will be 0, so going on decreasing, decreasing, decreasing. If I join all points, we get the shape in between 0 to pi, the shape of sin x curve. So if you extend the graph in between 0 to pi, it is like a shape. Suppose simple smooth curve I am drawing, not only in between 0 to pi, it will repeats the shape like this. If you draw the construction, it will be a simple graph. rough plotting only, 0 to pi, and it will be pi by 2, and it will be 2 pi, it will be minus pi by 2, it will be minus pi, it will be minus 3 pi by 2, it will be minus 2 pi. The shape is like this. At 0, 0, at pi it will be 0, at 90 it will be 1 plus 1, and it will be minus 1, it will be minus 1, it will be plus 1. So based on giving x input, this is x-axis and this is y-axis. X is input and y is output. Now the minimum height of the graph is minus 1, maximum height is plus 1. So range, now from graph I extract to important technical words, right, concentrate, domain and range. Two important technical words are now I am giving, mostly used in not only in trigonometry branch, in many, for each and every function, two important words, domain and range. Domain. Now I am going to give the definition of domain. Domain is nothing but input values of x, meaningful values of x, defined values of x, total minus undefined values of x, and boundaries of x-axis. Now I am giving domain for the sin x function. Domain as input for x, any real value. If you put any real value, it is R is a real scale, real number system. If you give any value minus infinite means any real value, if you put in place of x, sin is defined by knowing allied angle knowledge, by knowing how to calculate the different angles by the method of allied angle conversion. For odd multiples of 90 there is a change for sin, for even multiples of 90 there is no change. Like that the values can be calculated, not only standard, maybe quadrantal angle or any angle can be calculated, a derived angle also calculated by knowing knowledge of allied angle. Now if you put x any real value, y is defined, so therefore x domain is nothing but domain. Sin x is a trigonometric function, domain is R. Now function mapping from R to, okay, y values, no doubt it will be in between -1 to 1 only. It may not exceed +1, it may not down less than -1. So never sin x less than -1, no graph, there is no graph above +1. It is a y coordinate +1 and y axis boundary it will be -1. So y axis boundary is in between -1 1. That boundaries is lower limit and upper limit, minimum value and maximum value, extreme values, name called extreme values. The sin x graph in between -1 to 1, it will be bounded in between -1 and 1, and it will be continuous like this, a curve continuously like wave shape. Sin x is important trigonometric sine function. If you know very well sin x, the remaining all similar and very simple. So brief study about sin x function. The graph is like continuous curve, it will be bounded in between -1 to 1 and y equal to sin x. Many observations in future, it will be odd or even, it will be periodic or not, it will be the domain, codomain, extraction, and nature of symmetry, origin symmetry or not, sin x inequalities and sin x trigonometric solutions, and sin x various properties and features can be calculated with the graph only, odd even nature, periodic nature. So sin x is the trigonometric function whose mapping from domain is R real and range is -1 to 1. So sin x trigonometric function. My dear students, already we discussed about graph of sin x. Now I am going to cover remaining graphs, cos to cot. In detail, graphs construction and periodic property and extreme values concept, minimum maximum values, indirectly range, lower and upper limits of the graphs in graphs chapter separately. Now my main view is, today I am going to give domain range table of standard trigonometric functions. So cos x graph, similarly by giving x input we get y, x values on x axis, y values on y axis. Sin x it will be like start from 0 and up and down like this wave. Here cos 0 value, if it will be 0, cos 0 1, cos 90 0, cos -π/2 0. So graph is like this. Okay, so maximum value is +1 and minimum value is -1. So cos x is a trigonometric function mapping from domain for any real value of x, the cos x is defined. Therefore cos x is a trigonometric functions mapping from R to -1 to 1. Here also minimum height is -1 and maximum height is +1. So cos x is a trigonometric cosine function mapping from R real number set, and codomain indirect it is a range -1 to 1, minimum height and maximum height. So cos x graph. Many observations from the graph of cos x, like symmetry and odd even property and periodic property and bounded and equation, general solution of cos x 0. Next like inequality, many more observations in future. Now I am going to construct tan x. For giving x values we get y values. So f of x equal to tan x is our graph. So it will be shaped like this. By giving x value 0, tan 0, 0 and 45, 1 and 60 root 3, 90, it will be like not defined. So if there is a construction like this, 0, tan 90, it will be like this, at a 0 it will be like this. So the graph is like asymptote at pi by 2. If it is pi by 2, it will be like this, it will be minus pi by 2. So the graph is like this. The shape of graph tan x, it is like asymptote. The tangent meet at infinite but not exactly touch and not intersect the graph. The shape of tan x is like this curve. Here if you go by extension, either left or right, to get the same shape. At 0, 0, at pi by 2 it is undefined, not defined, the asymptote, and pi again it will be 0. And like this. So the shape is like this, like curvature. The shape is like this. Okay. So tan x curve from graph tan x domain. If you put tan x in previous examples, f of x sine trigonometric function, f of x cos x, and now we are discussing tan x. Now I am giving domain and range of three functions. Once again, sin x function domain is R, boundaries of x-axis, domain R, and the range is -1 to 1. So sin x is a trigonometric function mapping from -1 to 1, or mapping from R to -1 to 1. Cos x, similarly, same effect, same results, domain and range. For tan x, the graph is okay. The boundaries of y-axis indirectly range. It will be y-axis, it will be x-axis. In x-axis, the graph not defined at some values. If it is x pi by 2, y value not defined. If x value some 3 pi by 2, y value not defined. So for odd multiples of pi by 2, there is no value for tan x, therefore not defined. So for domain, already I told the definition of domain, total real values. We are talking about real functions, so domain meant nothing but total minus undefined. So now I am giving definition, total as R and undefined is odd multiples of pi by 2. So R minus set of domain of tan x. Or if you go by like this, in detail there is a graph, variation of graphs, don't worry. So domain is defined is equal to total minus undefined. Total is, we are talking about real, minus undefined is odd multiples x as that x equal to odd multiple means 2n plus 1 into pi by 2, n belongs to z. So total minus undefined is defined is domain. Or if you observe the graph at x pi by 2 not defined, tan x at 3 pi by 2 minus pi by 2 minus 3 pi by 2, for all odd multiples of pi by 2 tan x not defined, therefore you have to delete the undefined values from the defined values, so r minus of that. So my dear students, sin x and cos x and tan x in detail, there is a discussion completed, but in future complete structure of graphs we'll discuss in continuity, discontinuity nature, in differentiability nature, in domain nature, odd and even, and symmetry property, inequality and periodicity. Many more observations we come across in future. Serial number, function, domain and range. Okay, now for convenient, now I'm giving the serial numbers. Function as sine, cos, tan, cosecant, secant and cot x. Domain is R, tan x, R minus x as that x, 2n plus 1 into pi by 2 odd multiples. And the domain range also I am giving Cosec, don't worry. Cosec as a 1 by sine 0 all multiples of n pi, where n belongs to z. Here also n belongs to z. Cosec 1 by cos. 1 by cos means cos should not be 0. Means it will be total minus identify odd multiples. Cot cos by sine or 1 by tan. Sine. So sine means r minus x as that x n pi n belongs to z. R minus n pi, r minus 2n plus n into pi by 2, r minus n pi. If you observe the graph, if you observe the tabular form, tan and secant x domain is same. Cosec and cot also same, because cosec is 1 by sine, cot is cos by sine, denominator should not be 0. So denominator of sin x 0 or n pi, cosec means 1 by sine, denominator 0 n pi, therefore the construction. Now range. Range extracted with a different meaning. Sin x range from graph, minimum height and maximum height, it will be minus 1 to 1. Cos x also minus 1 to 1. Tan x, if you have already constructed a graph today, tan x graph boundaries of y-axis as r means minus infinite to plus infinite, y-axis boundary. Cosec, if you observe the graph of cosecant x reciprocal of sine, the graph not lie between minus 1 and 1 means less than minus 1, more than 1. So here the space not sufficient. Now I am giving a conclusion here. Cosecant x value less than or equal to minus 1 or cosecant x value greater than or equal to 1 means it will be like this. Less than minus 1, more than 1, but no value in between minus 1 to 1. That is important observation. Less than minus 1, more than 1. Similarly, for sec x also the same story. The range. The graph, no graph in between minus 1 to 1, therefore less than minus 1, more than 1, same. So the range of secant, cosec both, it will be like this, minus infinite to minus 1, union 1 to infinite. Now cot, if you observe the cot like tan, but the curvature is different, so cot boundaries also, if you observe same graph, it will be extended like this, r. So like minus infinite to infinite, like tan x. Now my dear students, important tabular form, domain and range table. For sin x it will be r domain and range is minus 1 1 closed interval minus 1 and closed interval minus 1 to 1 closed interval minus 1 comma 1 close. So in between minus 1 and 1 and also includes the values minus 1 and 1. Cos x domain is r and range is minus 1 to 1. Tan x all real values. Cosecant x domain is tan x domain is r minus x is the x odd multiples of pi by 2. Cosecant x 1 by sine should be 0. Total minus sin x value 0. R minus x is the x n pi n belongs to z. And cosec range, if you observe the graph, it will not lie between minus 1 and 1. Therefore less than minus 1 and more than 1. Same secant x. R minus cosec as 1 by cos 0, total minus cos x 0. Cos x 0 means it will be like odd multiples of pi by 2, and range is same idea like cosec. Cot as cos by sine 0, so r minus n pi, and range from the graph boundaries of y-axis r. So if you observe the graph, if you observe the table, sin x and cos x having same range, and tan x cot x having same, tan x and cot x having same range r, and cosecant secant x range having minus infinite minus 1 close union 1 to infinite. Now this is a simple introduction about domain and range table. My dear students, majority of questions link in future in trigonometry, the graphical construction is useful in solving trigonometric equation, in inverse trigonometric. Basic knowledge of domain and range idea, very very essential. So concentrate regarding graphs. Okay. Now, in trigonometric ratios chapter, particularly frequently used results, repeated results, frequently used results. Some standard expressions, not for mugging or not for by having the things of some standard trigonometric expressions, but a few questions based on frequently used results. Next, elimination idea. By knowing by arrange relation between variables and constants by making use of three trigonometric identities. Already simple discussion on elimination concept. Next, like special angles means coterminal, complementary and supplementary right angle on that special angles calculation, and simple inequalities by finding minimum value, maximum value based on the conditions given. Okay, the popular inequality as am greater than or equal to gm greater than or equal to hm. Arithmetic mean greater than or equal to geometric mean greater than or equal to hm. Based on that, few questions like a standard relation. Suppose sin square theta plus cosec square theta always greater than or equal to 2. By make use of that identity, that formula am greater than or equal to gm. So now in detail there is a discussion, don't worry. For standard results, frequently used results, problems based on this, and elimination problems, and special angles like supplementary, complementary, and inequalities using AM, GM, HM technique, and limits of trigonometric ratios, and from the graphs we can learn many more things, and the use of trigonometry in geometry, geometry calculations, in circle concept, or in finding sectors. Not only trigonometry is the branch useful in many more branches. In calculus, the utilization of formulae, each and everything linked with the function. Trigonometry is nothing but function. Our discussion about trigonometric ratios chapter, right angles. Right means 90 degrees minus theta, 90 degrees plus theta, 180 minus theta, 180 plus theta, 270 minus 270 plus 360 minus 360 plus theta. Combination called allied angle. So a special classification of angle is nothing but allied angle. Allied angle results useful in various situations, in finding components, in finding simplification of allied angle problems, and projections. So now I am going to give formulae, not by mugging, not by hatting the results, not required. A simple method. Now I am going to express how to memorize the results, how to pick up the results, how to get the right angle formulas. For odd multiples of 90, there is a change. For even multiples of 90, there is no change. Change means, with example, there is a clarity. Sine of 90 minus theta. Now my method, odd multiple and even multiple. Now 90 degrees minus theta, 1 into 90, 1 is here odd. Now for odd multiples of 90, there is a change in trigonometric ratio takes place. Sine change to cos, and the angle theta as it is. So up to this stage, sine of 90 minus theta is cos theta. Up to this stage, 50% completed, and remaining 50% it will be decided with the symbol before cos, symbol whether positive or negative will be decided. Now according to multiples of 90 diagram, this is 0 into 90, 1 into 90, 2 into 90, 3 into 90, 4 into 90, like that. A cycle. 0 means 0 into 90 diagram, 1 into 0 into 90, 0, 1 into 90, 9 degrees, 2 into 90, 190, 3 into 90, 270, 4 into 90, 360. So here 1 means here 1 as it is in the diagram 1. Minus means backward, plus means forward. Now minus means it is the first quadrant. According to the sign convention of various trigonometric ratios, in first quadrant all trigonometric ratios are positive. In second quadrant sine cosec positive, remaining all negative. In third quadrant, tan cot positive, remaining all negative. In fourth quadrant, cos sec positive, remaining negative. So here one odd, here one odd, okay, there is a change, sign takes place, cos theta as it is, 50% completed. Now I am searching for the symbol whether positive or negative. In maths, only one symbol it exists, not both at a time. So minus theta, after one here in diagram, tools of 90 diagram, minus means backward, it will be first quadrant. So looking symbol for the given question, sign, not for the cos, for the question sign, for question is sign of sign trigonometric ratio. So looking the symbol for also sign in the first quadrant, it is positive, not for the cos. Symbol is looking symbol for the given question sign, so it will be positive. So sign of 90 minus theta as cos theta. I think it is clear. Now I am going for sine of 90 plus theta. Similar procedure, 1 into 90, one odd number. Here 0, 1, 2, 3, 4. One odd, there is a change, sine change to cos. Changes also sine to cos, cos to sine. Tan to cot, cot to tan, and secant to cosec, cosecant to secant. That is the changes takes place for odd multiples of 90. 50% problem completed. Now looking for the symbol, whether positive or negative, it will be decided by the same method already explained in previous example. So one here, plus means forward, it is in second quadrant. In second quadrant, given question is sign, it is positive. Don't take symbol for the cos, only symbol for the given question, it will be like this. Now I am going for sine 180 minus theta. Now I convert 2 into 90, 2 even number, no change. But here is one odd, there is a change, but 2 even, no change, sine as it is, 50% completed. Remaining 50%. Multiples of 2 into 90, 2 into 90 minus means backward. In backward, now question is sine, so the symbol is 2 here. Minus means backward, it is second quadrant, question sine. In second quadrant, sine cosec positive. Next, one more example. Sine of 270 plus theta. 3 into 90, 3 odd, there is a change, sine change to cos, cos theta, 50% problem completed. 3, here 3 plus means forward, it will be fourth quadrant, cos sec positive and remaining are negative. Fourth quadrant actually, here it will be, question is sine, so sine in fourth quadrant is negative, so minus cos theta. I think it is clear. One more example, cos of 360 minus theta. It will be like this, 4 into 90, 4 even number, no change, it will be cos theta. 50% completed. Remaining 50%, 4 here, 4, minus means backward. In fourth quadrant, cos sec positive, given question is cos positive. Right. I think allied angle combination 90 minus theta, 90 plus theta, or 190 minus theta, 190 plus theta, 270 minus theta, 270 plus theta, 360 minus theta, 360 plus theta. All allied angle combination, same procedure. Now I am going one more example. Secant 270 plus theta. One more example. Last example for the clarity of allied angle combination. Right. 3 into 90, 3 odd. There is a change, secant change to cosec theta. 50% completed. Now 3 here and plus means forward, fourth quadrant, cos sec positive, given question is sec, cos sec, so it will be positive. Like that, many more connections. So I think here this rule follows. For odd multiples of 90 there is a change, for even multiples of 90 there is no change, and also taking granted a sign scheme of various trigonometric ratios according to the rule, thumb rule. In first quadrant, all Sachin Tendulkar centuries, all silver teacups, all students take care. First letter A, all are positive in first quadrant. Second, when all silver, sign, first letter is S, sign and cosec positive, remaining negative. And here tan cot, all silver teacups T. First letter T, tan and cot positive, remaining negative. In last cups, all silver teacups, cos cups, or all Sachin Tendulkar centuries C. First letter C, cos and sec positive, remaining negative. By keeping a sign convention of various trigonometric ratios and odd multiple and even multiple, I think, my dear students, I think it is full clear about allied angle calculation. Now I am going to use Frequently used results in trigonometric ratios in trigonometric function chapter. Frequently used results means not only in first chapter helpful various trigonometric expressions in coming chapters like multiple submultiple transformation or simplifications, mostly used in majority of calculus questions linked with functions, means trigonometric functions only. So in inverse trigonometric, in hyperbolic function chapter, in inverse hyperbolic, ordinary trigonometric functions, in identities, in equations, expressions, in inequalities, many more situations, majority of questions linked with in limits evaluations, in differentiation and integration of trigonometric expressions. So frequently used results in trigonometric ratios. Sin power 4 plus cos power 4, sin power 6 plus cos power 6, sin square theta plus cos power 4 theta, as cos square theta plus sin power 4 theta, as 1 minus sin square theta cos square theta, and it will be 1 minus 3 sin square cos square, 1 minus 2 sin square cos square. Now I am going to prove one result. Sin power 6 plus cos power 6. Now it will be like this: sin square theta whole cube plus cos square theta whole cube. Now it is in the form a cube plus b cube. A cube plus b cube as a plus b whole cube minus 3ab into a plus b. So a cube plus b cube as a plus b whole cube minus 3ab multiplied by a plus b. So it is the algebraic formula. Identity, trigonometric identity is 1, trigonometric identity is 1, 1 cube is 1, 1 minus, I think it will be 3 sin square cos square. So frequently used result in trigonometric ratio. I think it is clear. Simple procedure for first one also like that. Sin square square plus cos square square. Use a square plus b square as a plus b whole square minus 2ab. Here also a as sin square, b as cos square, a plus b whole square. A square plus b square as a plus b whole square means sin square plus cos square whole square minus 2ab 1 minus 2 sin square theta cos square theta. Now I am going to prove third frequent result. First one, second one and third one. Now I am taking first and second. Now rearrange. I am going to prove this left and this is right. Now rearrange means without disturbing, without altering question. Cos square this side, sin square minus cos square. Now cos power 4 that side, sin power 4 minus cos power 4. Now right hand side split into factors. Sin square square minus cos square square, a square minus b square, a plus b multiplied by a minus b. If you observe, this is identity 1, now left and right equal, sin square minus cos square. I think clear. But how to get third one? Okay, first and second okay. And how to get third one? Third one means sin square plus cos power, sin square theta plus cos power 4 theta equal to cos square theta plus sin power 4 theta equal to 1 minus 2, 1 minus sin square theta cos square theta. Now I am taking sin square cos power 4, sin square cos power 4 as cos square theta into cos square theta. Now sin square theta. Cos square is 1 minus sin square multiplied by cos square. Cos square is 1 minus sin square. Now again multiply sin square and multiplication with distributing bracket. Sin square cos square, it will be 1. So 1 minus sin square cos square. Like this, many more frequently used results can be determined by simple mathematical algebraic operations. Next I am going to discuss a simple inequality formula. Based on that, many more trigonometric calculations, even in trigonometric inequality problems, even in minimum values and maximum values concept, in equation chapter or in inverse chapter, useful result. Not only in trigonometry, in algebra, in quadratic theory of equation chapter, inequalities chapter. So basic formula: AM greater than or equal to GM greater than or equal to HM. AM is A, GM is G, HM is H. Now I am going to give formula, proof of this, and I make use of this formula in many more situations. Right, let us consider two positive numbers, A and B. A and B are two positive numbers. A means arithmetic mean, A plus B by 2. Geometric mean or mean proportional is root AB. This is A and this is G. Now first I am going to prove this result. Based on that, many more questions linked with the inequality. So for the proving inequality formula, basic formula, from this only weighted mean and weighted GM, weighted HM, and power mean theorem, many inequalities, mostly used formula this is. Now that's why I am going to prove relation, proof of the statement A greater than or equal to G greater than or equal to. Now I consider A minus G. So this will be like this, LCM. Now it will be a form like root A minus root B whole square by 2. It will be A minus G. Now here A and B are two positive numbers. No doubt the square is positive, denominator 2 positive. So this will be positive. If the one equal, for one case, one possibility, if A and B equal, two numbers equal, this will be 0. So greater than or equal to 0. So A minus G greater than or equal to 0. A greater than or equal to G. Okay. Now I am going to take G and H and make one more relation. Then I am talking about combined formula. Right? I think A greater than or equal to G proved. Now consider G minus H. What is G? Geometric mean proportional. For two positive numbers, G is root AB and H is harmonic mean. 2AB by A plus B, or 2 by 1 by A plus 1 by B is HM, harmonic mean. So now I am using G minus H. G is root AB, H is 2AB by A plus B. Now it will be after that, now calculation of G minus H. Already in previous step A minus G calculated. Now I am taking by considering A minus G, the A minus G term, A minus G amount, it will be greater than or equal to 0, proved. Similarly, one more connection with G and H. Now that's why the reason for taking G minus H consideration. Now I am checking for the symbol, whether positive or negative or equal. Now I am giving statement. Suppose if I take root AB common, it will be like this now. If I take root AB common here, A and B are positive, no doubt root AB also positive. If you take root AB common, it will be like root AB, AB, right? Now it will be root AB and A plus B is LCM and it will be A plus B minus 2 root AB. So A and B are positive, no doubt root of A plus B positive, and also it. Now the inner term as like this, root A minus root B whole square. If numbers equal, this will value 0. If numbers equal. Other possibility, square means always positive. So greater than or equal to 0, G minus H greater than or equal to 0. Now, previous calculation, A greater than or equal to G. Here, G greater than or equal to H. Combine a formula A greater than or equal to G greater than or equal to H, because A greater than or equal to G proved, and G greater than or equal to H proved. So the final formula, arithmetic mean greater than geometric mean greater than H harmonic mean. Okay. Popular formula, inequality formula, useful in many more. My dear students, a right angle theory part, a right angle formulas, how to extract without mugging, without adding the things. No need of mugging the formula of a right angle. With a technique, odd multiples of 90 there is a change, even multiples of 90 there is no change, and according to sign scheme we extract right angle formulas. And also mostly means frequently used results, already a few examples already I discussed, and popular formula AM greater than or equal to GM greater than or equal to HM also I finished.